Hello! Welcome to Teach Me Maths. My name is Jonathan Hicks and today we're doing indices. Now I've gone through the laws of indices and explained where they come from in another video. So if you want to understand the laws of indices, go and watch that video. In this video we're just going to be practicing. I'm going to quickly summarize the laws of indices and then we'll just do a bunch of questions and you can see how they work in practice, how you use them to actually solve questions and problems in maths. So quickly then, the first law of indices is the adding law. When you're multiplying with powers, you add the powers. The second law of indices, when you're dividing, you subtract the powers. Third law of indices, anything to the power 1 is itself. But often more importantly with that one, if you have something without a power, it really has a power of 1, not 0. Fourth law of indices, anything to the power 0 is 1. And the final law of indices, anything to a negative power is 1 over the positive. You get exactly the same thing on the bottom without the minus sign. So those are the 5 laws of indices. And you need to learn those off by heart really. Now there are a couple of other laws of indices that we haven't covered. You don't really need those until you get into the more advanced maths. So when we do algebra, and we'll be doing indices with algebra as well when we get there, and I'll go over the more advanced laws of indices that you need for that. But for now we're just going to stick with numbers and we're just going to cover those 5 laws I've gone over. So our first example, in fact the first few examples are all going to be questions where you have to evaluate something. That's often what they'll put in the question, evaluate. Now what that means is you have to find the value of it. So these are usually fairly straightforward. You just work out what the power gives you. So if we have 3 to the power 4, for example, then you just have to work out what 3 times 3 times 3 times 3 is. Yeah? The power here means you've got 4 3's multiplied together. So you just work it out. That's all evaluate means. Find the value of this thing. Well, 3 times 3 is 9. Times that by another 3, 27. Yeah, 3 9s are 27. Times that by another 3, 3 times 27 is 81, I think. So if you evaluate 3 to the power 4, it's 81. Let's try another one. 6 to the power 1, they love throwing in things like this. Well, anything to the power 1 is itself. So anything with a power 1, you can just write it without the power. Yep, there's like an imaginary power 1 that's here, but most of the time we don't bother write it. So if you end up with something to the power 1, just leave it as the number itself. Okay, another one. 8 to the power 0. Well, hopefully you'll remember from the laws of indices, anything to the power 0, doesn't matter what this number is 1. So 8 to the power 0 is 1. That's another one you just got to remember. Very easy to do these questions in practice as long as you can remember the appropriate law. So anything to the power 1 is itself, anything to the power 0 is 1. Let's try one with a negative power, 5 to the minus 2. So again we've got to work out what this is. Well, negative power, think 1 over the positive. So it's 1 over exactly the same thing, except the power, instead of being minus 2, is positive. It's a positive 2. Now it says evaluate, find the value of it, so we've got to work out what this 5 squared is on the bottom here. Well, 5 times 5 is 25. So if you had to evaluate 5 to the power minus 2, it would be a 25th. Alright, so those are the simpler kind, that's the evaluate sort of question. You get another kind of question where you have to simplify. That's usually what the question says. We write that up here. Simplify. Now sometimes it'll say other things like simplify using positive powers or leave it as a single base number to a power. But if you're dealing with numbers and it has simplify, whatever it is in there, then you don't need to work out what the final answer is. You just have to use the laws of indices in some way. I'll show you a few examples and then it should make sense. So if you had 4 cubed times 4 to the power 6. Now we're multiplying, so first law of indices says we add the powers. So it's as simple as 3 plus 6 gives you 9. The base number never changes. So that will be 4 to the power 9. And because it says simplify and not evaluate, you don't have to work out what 4 to the power 9 is. You just leave your answer like that. This is simpler than this. There's less writing involved. So we prefer this in maths. Okay, let's try division 1. If you have 7 to the power 8 over 7 cubed, or you're dividing, so you subtract the powers. Remember, a fraction means divide. So it's 8 minus 3. That gives you 7 to the power 5. And again, you don't have to work out what that gives you. If it just says simplify, it's simpler. Alright, let's try a slightly more involved one. So 9 to the power 4 times 9 times 9 to the power 7 all over 9 to the power 6. This is a big fraction. I've got all this stuff on the top and I've got this thing on the bottom. Now with fractions, you just work out the top of the fraction, work out the bottom of the fraction, and then finally do the division. So on the top, we're multiplying, so you just add all the powers, and you need to be very careful here. This 9 has a power. I know it doesn't look like the power there, but remember, if a number doesn't have a power, it does really, and the power is 1. So this is actually 9 to the power 1. There's an imaginary power 1 there. So when you're adding the powers here, don't think of that as nothing, it's a 1. So it's 4 plus 1, which gives you 5, plus 7 will give you 9 to the power 12. On the bottom, well, there's nothing else to work out there. You're just going to keep your 9 to the power 6. And then we're dividing. It's a fraction. So you subtract the powers. 12 minus 6 gives you 6. So the final answer to that would be 9 to the power 6. Alright, just make some space. And do a couple more. So 2 cubed times 2 to the power 5 on the top of the fraction. And on the bottom of the fraction we're going to have 2 times 2 cubed times 2 to the power 4. So work out the top. You're multiplying, so you add the powers. The base number never changes. So it's 2 to the power of 3 plus 5, which is 8. On the bottom, you've got 2 times 2 cubed times 2 to the 4. Add the powers. Remember the power 1 that's here. So it's 1 plus 3 gives you 4, plus another 4 gives you 8. 2 to the power 8. Now we're dividing, so you subtract the powers. 8 minus 8 gives you nothing. But remember, anything to the power 0 is 1. Which makes sense if you think about it, because 2 to the power 8 divided by 2 to the power 8, if you're dividing anything by itself, you're going to get 1. So the simplified version of this would just be 1. Okay, let's try one more. So 5 cubed times 5 to the power 4 on the top of a fraction. 5 to the power 6 times 5 to the power 8 on the bottom. So again, work out the top, work out the bottom. You're multiplying, you add the powers. 5 to the power 7. On the bottom, again, multiplying, so you add the powers. 6 plus 8 gives you 14. Now we subtract the powers. Now you must always start with the first one and subtract the second one. So it's 7 minus 14. It's not 14 minus 7. You must start with the 7. So 7 minus 14, we've got to work with negative numbers here. If you think about it, if you imagine a number line, if 7's up here and 0's here, if you're taking away 14, you're going down by 14. It's going to take you 7 to get down to 0. So from your 14, you're going to have another 7 left. So you're going to get all the way down to minus 7. So the power here, 7 minus 14, is actually minus 7. But this is a negative power. If we wanted to now, we could then rewrite it as a positive. If the question says express as positive powers, you can't leave your negative powers. So in this case, it would be 1 over exactly the same thing, except the power is now positive. There's some debate as to whether or not this is simpler than this. These two things are both as simple as each other, really. And in maths, sometimes you would prefer this, and in other situations, you would prefer this. So it's a personal choice, really, unless you have a wider context to consider. But if it says leave it as positive powers, you must convert the negative power into the fraction like this. So that'll be your final answer. So there you can see just a few different ways of using the laws of indices. And actually in practice, when you know the laws of indices, it's very easy to do. The arithmetic's not particularly challenging. 3 plus 5 is 8 is about as hard as it gets most of the time. Negative numbers can make it a little bit trickier, and you need to be careful of that. But generally, as long as you know the laws of indices, you should be fine. So if you haven't learnt them yet, go away and learn them, and then practice as much as you can. My name is Jonathan Hicks, and you're watching Teach Me Maths.